right, so if you haven't watched the previous example, it's a good idea to start with that one. So it says this is a more complex example, but we have to balance the following reaction in acidic solution. So in this case, we actually have an oxygen involved, which makes this much more complicated. And it's important to notice that this is in acidic solution. So in the previous question, we found that the oxidation state from MnO4 minus, the oxidation state of Mn is +7. Over here, it's +2. I is -1 here, and it's 0 here because it's elemental. So I went from -1 to 0. It lost electrons, so this is your oxidation half reaction. Permanganate went to manganese 2+, which in this case is gaining electrons, so this is your reduction half reaction. So now we want to write out our half reactions. So for our oxidation half reaction, we're going to have I minus aqueous yields I2. It happens to be a gas in this case. So this is our oxidation half reaction. Now for our reduction half reaction, we're going to write out the other half reaction, which is MnO4 minus aqueous yields Mn2 plus aqueous, like so. So this is our oxidation and reductions half reactions. The next thing we want to do is we want to balance the mass. So this would be step 3. Balancing the mass means simply balancing the atoms. So for step 3, we want to balance the atoms. In this case, we have 1 I on this side and 2 on this side, so we can just put 2I minus aqueous yields I2 gas. And this side is a little bit more complicated because we have oxygens. We need to balance out with waters. Specifically, we need to take MnO4 minus aqueous yields Mn2 plus aqueous, and we have oxygens here, so to balance the oxygens we add 4 waters liquid. All right, so this gives us our 4 oxygens, and it tells us that it's an acidic solution, so we need to add H pluses to balance out the hydrogens, so we need to add 8 H pluses over here. So this now balances out our mass. We have on this side 8 hydrogens and 8 hydrogens, 1 manganese and 1 manganese, 4 oxygens and 4 waters, so 4 oxygens. So now we've balanced our mass. Note that when there's oxygens involved, we have to balance it with waters because this is an aqueous solution, so there is water around. And then because it's an acidic aqueous solution, we balance with the H pluses here. So the next thing we need to do is we need to add in the electrons to balance out the charge. So step 4 is to balance the charges by adding electrons. In this case, we have 2 minuses on this side and I2 on this side, no minuses. So we're going to get 2I minus aqueous yields I2 gas plus 2 electrons. Now we have 2 minuses and 2 minuses, they balance. Note that for your oxidation half reaction, your electrons have to be products, okay? So if you have this backwards, maybe you have this as a reduction half reaction, but you need to make sure that your electrons are products or electrons are given off because oxidation is losing electrons. Note that we're balancing the overall charge, not the oxidation states. Up here, let's take a look. We have 8 H pluses, so 8 plus and a minus, which gives us an overall charge of +7 on this side. On this side, we have +2. So we have 7 plus and 2 plus, so we need to add 5 electrons. So it's going to be 5 electrons plus 8 H plus aqueous plus MnO4 minus aqueous yields Mn2 plus aqueous plus 4 H2O liquid. All right, so this is basically our charges here. So now we have 5 minus and 8 plus, which is 3 plus, and a minus is 2 plus, and a 2 plus. So now we've balanced our charges on both sides of the oxidation half and the reduction half. Step 5 is to equalize the electrons between these two reactions. So in this case we have 2 electrons, in this case we have 5 electrons. So when we add the two reactions together we need the electrons to cancel out. So the lowest common multiple between 2 and 5 is 10. So we want to multiply everything here by 5, which is 10I minus aqueous yields 5I2 gas plus 10 electrons. Now we need to multiply everything here by 2, which is 10 electrons plus 16H plus aqueous plus 2MnO4 minus aqueous yields 2Mn2 plus aqueous plus 8H2O liquid. So now we have 10 electrons and 10 electrons. Now what we need to do is rewrite this and then cancel out everything that's alike on both sides. But you'll notice in this case, the only thing that's going to be alike is the electrons, because this didn't have any oxygens in it. So there's not going to be any hydrogens or H pluses or waters. So we only need to cancel out the electrons. So I'm just going to not bother to write the electrons out. All right, so I'm just going to do two steps in one, if you will. So I'm going to write the first reactant, which is the 10I minus aqueous. Now I'm going to skip the electrons because the electrons I know are going to cancel. So plus 16H plus aqueous plus 2MnO4 minus aqueous yields. So I've written out all the reactants for both reactions. Note again that I canceled out the electrons. Now I'm going to write all the products. 5I2 gas plus 2Mn2 plus aqueous plus 8H2O liquid. All right, so now I've written out all of the products and the reactants. The nice thing about this is you could check your answer. All right, so the first thing I'm going to do is check the elements. I have 10 iodines, and 5 times 2 is 10 iodines. I have 16 H pluses and 8 waters, or 16 H's. Okay, I have 2 manganese, I have 2 times 4, which is 8 oxygens, and 8 waters has 8 oxygens. So the masses work. Now I got to check the charges. On this side I have 10 minus and 16 plus. So that gives me 10 minus and 16 plus is 6 plus 2 more minuses is going to be 4 plus. On this side I have two pluses, so I have 4 plus. So the charges balance it, the atoms balance, and there's not some common multiple between all these things. So this is the balanced redox equation in acidic solution. This absolutely takes practice, so please practice with this.